Okay, in this example, we have 1 kilogram of material, 9,000 joules of heat leaves the system. So our system, let me just go ahead and sketch this. So we've got a system here. The mass is 1 kilogram. We're told that 9,000 joules of heat leaves the system. So I'll just draw it that way since I know that it's leaving. And enters the surroundings. The temperature at the surface of the system is 300 Kelvin, so that means the temperature at the surface here is 300 Kelvin. Determine if the process is internally reversible, internally irreversible, or impossible for the following conditions. So what we're going to do is draw a control volume that surrounds the system, and we're going to apply the entropy equation to that system, and then take a look at the entropy generation term. So we'll write out the entropy equation. So we're writing it out in the form, we're writing it out in terms of delta S here. There's no inlet or outlet into this. This is not a rate form. So here's our entropy equation. We'll rearrange this to solve for the entropy generation, and since there's only one there's only one location where there's heat crossing the boundary, I'll just rewrite in terms of that. So, and then also use the specific entropy. So the mass times the change in specific entropy, of course, is the total change in entropy. And then, as I mentioned, we'll write it in terms of Q out in just a moment here. The temperature where the heat transfer is occurring is right at the surface. So the temperature there is the surface temperature. So I'll make a note of that. And since I wrote this in terms of Q out, I'll just change my sign here and put it in terms of Q out. All right, we're given some data here, so let's go ahead and plug that in. So we're given that it's 1 kilogram of material, and we're told that we're dealing with 9,000 joules, and the temperature was 300 Kelvin. All right, so let's go ahead and evaluate for case A. For case A, we're told that the little delta S is minus 30 joules per kilogram Kelvin. So when we plug in the values for this, we'll have the first term will be minus 30 joules per Kelvin because we're multiplying it by 1 kilogram. And the next term should be, let's see, that'll be 30 joules per Kelvin. So in the first case, case A, the entropy generation is 0. So that means that we have an internally reversible process. For case B, we're told delta S is minus 20 joules per kilogram Kelvin. So when we plug in the values for that, we'll end up getting 10 joules per Kelvin when we plug that in. So that's greater than 0, indicating that that's internally irreversible. And then in the last case, the delta S is minus 40 joules per kilogram Kelvin. So when we plug that value in, we're going to get the entropy generation is minus 10 joules per Kelvin, which is less than 0. So that one is impossible. That would violate the second law. All right.